Okay, so the first thing is we've learned about equal values method, okay, and the substitution method for solving systems, but these aren't the only types of ways to solve it. Okay, so let's skip on down to the first problem. So Jeanette, she's trying to find the intersection, a point of these two lines. Now remember, intersection just means two lines that cross at some point, and that point where they cross is a solution. Or a coordinate, like an ordered pair, where you get an x and a y. Okay, and that's what we're looking for. We're looking for x. You got to find x and find y. And that's every problem. Find x, find y, or you're looking for like two different values. Okay, so she decided to use substitution to find the point of intersection. Her plan is to solve the first equation for y. So that's a key thing. She wants to solve the first equation for y, and then substitute the result into the second equation. So that means we're going to plug in. Okay, so we're going to take this first equation and we're going to solve it for y. So I'm going to take this first equation off to the side. 2x plus 3y equals minus 2. And we're going to solve it for y so that we can plug it in. Okay, so first thing is, if we're solving for y, that means we want y to stay on this side. So we need to move the 2x by subtracting it from both sides. Also 2 over 3. Now that looks like a fun equation, fractions all the way across. So let's see how this works out. All right, now we're going to take this, because remember, if this whole part of the equation equals y, that means you could say that this is the same as y. Negative 2 over 3x minus 2 over 3 is the same as y, because there's an equal sign between. So if that's true, I could take all of this and plug it into wherever I see a y, because they should be the same. Okay, it's just written differently. So what we're going to do is we're going to plug in this expression into the other equation. So plug into other equation. Okay, so we're going to take the 5x, and then remember it's equal to y, so that's where we're going to plug it in right here. So negative 2 over 3 x, and I have to write kind of tiny because I've got these fractions in here. So basically I plugged it in for y, substituted that out. Okay, now solve it. Okay, so now first thing I bring down the 5x, not doing anything there. I want to distribute this 3. This is starting to look pretty fun, isn't it? Okay, so then I'm going to distribute the 3. Now, if I'm multiplying 3 times a fraction with the denominator of 3, remember those 3's just basically cancel out. And it becomes negative times the negative 2, which is positive 2, and then there's an x there. Okay, and then it's the same thing here, just without the x. So these 3's cancel out, negative times negative 2, positive 2. Okay, so now I notice that there's like terms on this side of the equation. That goes away, so now we have 7x equals 14. Last step, divide by 7. Remember the number that's always next to x, and we get x equals 2. Okay, but remember there's always two solutions to all these when you have two different variables, x and y. So now I'm going to take that 2 and plug it into one of the equations. It doesn't matter which one. Let's do the first one. Okay, so I'm going to take now, so we'll say find y. No, you're plugging into x, which is the first term, so I'm plugging it in there. 2 times 2 plus 3y equals minus 2. Okay, so now we just simplify and solve. So 2 times 2 is 4. And remember, we want y to be by itself. That's what we're looking for. So we're going to take away the 4. So we get 3y equals negative 6. Negative 2 minus 4. And the last step is divide 3. Okay, so then we get y equals minus 2. All right, now here's the thing. Remember that the point that you find is the point where the two lines intersect. It's a coordinate. So when you write your answer, you need to write it as a coordinate. 2 is the x, and the y is minus 2. So you write it in parentheses like that. Now the thing is, you want to check this. Okay, you want to check to make sure you're right. So we have to plug it in. So I'm going to do my check right over here. With that same point, I'm doing it sideways because I'm running out of room. And you have to plug into both equations. So I'm going to take the first equation and plug in the x and the y. Okay, so multiply here, 4, and that's -6. Okay, so 4 minus 6 is -2, so that works. And now I'm going to check the other equation. 5 times 2 plus, or sorry, not plus, minus, it's minus 3y. So 3 times the y, which is -2, equals 16. Okay, so now I got 10 plus 6. Does that equal 16? Yes, so that is the right answer. Now here's the deal. Whew, that was a lot of work. I just had to take a breath. There's got to be an easier way than that. Okay, because the last problems we worked on, they were a lot easier than that, but that took a while. So let's look at this in a different way. Okay, so that's what this is saying. Let's try to avoid the mess. Now, there's this other method called elimination method. Okay, to find the solution to Jeanette's problem without the complications and fractions of the previous problem. So let's look at this problem a little closer. Now, if I was to take say I'm just work out a note. I'm going to take that first equation, this one right here. Okay, and you guys don't need to write this. You can just watch. And then here's the other equation. I'm just going to write it up here. 5x minus 3y equals 16. All right, so remember we were talking about how if this is equal to this, that means there must be the same. So like, you know, like when we solve an equation and let's say I add 2 here, then I would add 2 here, right? You do the same thing on both sides. Let's say I added 16. Okay, like that 16 there. Add 16 here. Add 16 here. I can do that because it's the same thing on both sides. Now, if we're saying that the 16 equals all of this, then that means that if I add 5x minus 3y to this side, it's like I'm doing the same thing. I'm still balancing because technically they're the same thing, right? So if I add all these together, let's see what happens. Okay, so I add the like terms, so 2x and 5x. And now 3y minus 3y. Well, that's 0. So that can't actually goes away. But I also have to add up the other side, so -2 and the 16. That becomes 14. Hey, look, it's that same equation that we had earlier. Okay, so that's what we're going to do here. So we're going to take that, add that up, that goes away, and I have 7x equals 14. Holy smokes. Look at how we got to that last step, to this step, in one move. Whereas last time we had to like change it into this equation, and then plug it in, and then solve it, and then get there. That took almost like 5 minutes. We just did that in like 30 seconds, maybe less. Okay, now I divide 7, x equals 2. Boom, I'm done. I'm going to plug it in. Oh, that's a U, sorry. Just like I did before, to one of the equations. But guess what? I've already done this work. I did that right here. Okay, so basically the steps are the same. I'm going to solve it, and then y is going to be -2. And I get the same thing. Holy smokes, that was a lot easier. Because guess what? Sometimes there's easier methods to do in some situations than others. Okay, so now I want you guys to practice this one. Try this one on your own. All right, so I went through all the steps. If you notice that here when I added up this side, I basically added it. Okay, we're going to add both sides here. Basically those x variables canceled out, or the x terms canceled out. Whereas over here, the y terms canceled out. Okay, so now, again, I'm adding these two, which becomes 2y, because remember, that's a 1. Okay, then I solve and get it's 4. And then I plug in that 4, I solve the equation, and I get x equals 1. But don't forget to check. That's really important. I was going through some of these problems earlier, and I got it wrong, and I checked it, and I was like, oh, whoops, and I got the wrong answer. Okay, so the last problem we're going to go over here, it was Pat was in a fishing competition. Okay, so in a fishing competition at Lake Pisces, he caught some bass and some trout. Each bass weighed 3 pounds. Okay, that's probably important. So I'm just going to highlight it. Okay, and each trout weighed 1 pound. All right, so we've got two different things going on. So remember, when you're reading these, figure out the important information. And actually, I like to use blue, not pink. Okay, so Pat caught a total. Oh, there's that word total. You know what that means? That usually means equals. Okay, a total of 30 pounds. Okay, so he got 5 points in the competition. Now it's talking about something else. So first we talked about weight. Now we're talking about like points. He got 5 points in the competition for each bass. Okay, so 5 points for the bass, and that's the same, talking about the bass again, but it's talking about something else, talking about points. But then since each trout are endangered, okay, there's not very many of them in Lake Pisces, he lost 1 point for each trout he caught. And sorry, I wanted to do that again in blue, okay, because it has to do with the trout. And then Pat scored a total, oh, there's total again, that means there's probably another equation in there, a total of 42 points, okay? So write a system of equations representing the information in the problem. Solve this system to find out how many bass and trout he caught. There's our question. Okay, that's what it's asking for, but it's asking us to write a system of equations. So let's look at the first one. So the first sentence, we notice there's one factor of the bass, one factor of the trout, and all that adds up to pounds of fish. So the bass pounds plus trout pounds is equal to the total pounds, okay? So let's represent that with an equation. So it says every bass weighs 3 pounds. Well, bass, that's what it's asking for, so we're going to make that our B. And then the trout is the other one it's asking for, so that's our other unknown T, okay? So bass, 3 pounds for every bass, so we'll say 3 times the amount of bass is the pounds for bass. Then for trout, it's how many pounds? 1 pound for every trout, so 1 T. Okay, and then the total, we already know that it's 30 pounds. So there's our first equation. Okay, so now our next equation probably comes from it's about the points. Okay, so the points, bass points. Okay. Now it says he got points, 5 points for each bass, but then he lost points for trout because they're endangered. So we're not adding the trout points, we're subtracting them because you lose points for that. And that equals a total points. Okay, so the bass points, well, they're 5 points each, so 5 times the amount of bass, 5B, minus the trout points, which is 1T. That should add up to 42. There's our two equations. Now we're just going to solve them. Okay, so now we got to decide, okay, do I have a term by itself, okay, or should I use this new method like the elimination? Okay, well, let's line them up. Okay, so 3B plus 1T, 5B minus 1T. And some of you guys might already notice something that's going to help us here. Remember, the method's called elimination. Trying to eliminate something. Here we eliminated the y. Here we eliminated the x. What do you think we can eliminate here? The t. That's right, because we're adding these two together. So now 3b plus 5b, that's going to give us 8b. And you notice that goes away. Okay, the 1t minus 1t. Okay, so now 30 plus 42, that's 72. Last step, divide by 8. Well, not the last step, the next step. Okay, and divide by 8, we get 9. So B equals 9. Okay, so remember B represents the bass, so that's how many bass there were. Okay, but now we need to figure out how many trout there were. Okay, so now we got to plug it into either equation, doesn't matter. I'll plug into the first one because I like it. Okay, so we're going to plug in here, the B to there, 3B plus 1T equals 30. Okay, so now 3 times 9 is 27. Now remember, we're trying to get T by itself, so take away the 27. And we get 1T equals 30 minus 27, which is 3. Okay, and if it's 1T, sorry, I don't know if you guys can see that. If it's 1T, that's the same thing as T. You don't need to divide 1. So T equals 3. So that's how many trout and bass there are. But we need to write that out. Don't just put b equals 9 and t equals 3, that doesn't say anything. Okay, so the question is, how many bass and trout Pat caught? Well, Pat, write a sentence. Pat caught 9 bass and 3 trout. And that makes sense because he wanted to catch less trout than bass because that would take away points from his total. Okay? All right, now on the back side, this last problem in the notes, it says Annie was going to use elimination. She's ready to add the same value to both sides of the equation to eliminate the x terms when she noticed the problem. Okay, both x terms are positive. What do we do now? Well, in your groups, try to figure out, see if you can figure out what to do. Okay, so before we were adding up this side and this side, but the problem is if I add this and this, I get 4x plus 10y equals 18. But I don't have one variable to solve for anymore. I have 2 still. So that doesn't really help us because, again, we're eliminating. That's why it's called elimination, because we're eliminating a variable. But if I subtracted that side, that would do it. So if I subtract this from that, that will get rid of it. Okay, just like when we're solving an equation, if a term is positive, then I have to subtract it to get rid of it. Okay, so now 2x minus 2x, that goes away. And now these 2 positive terms, I subtract them. So 7y minus 3y. Well, that's 4y. So I basically have to decide, if I can just add them, they'll cancel. But in this case, they don't. So I have to subtract them. But that also means I have to subtract this side as well, 13 minus 5, which is 8. And there we go. Now it's a simple equation. Divide by 4 and solve. Okay, you guys solve the rest. Okay, so I got y equals 2. Then I plugged in the 2 and I got negative 1/2. So now that's great, but you need to check your answers. So plug them in and check them. So now you notice over here I plugged in the x, which is negative 1/2, and the y, which is 2. Now remember, I know you guys like fractions can be intimidating, but look, it's as long as that number you're multiplying is the same as your denominator, those just basically cancel out, and you're left with the number on top, negative 1. Okay, same thing over here. 2's cancel out, so I have negative 1. Okay, and then I just add these 2, and that equals 13, and that equals 5, so it works. So the answer, remember, write it as a pair. Okay, especially if it's not a word problem. If it's not a word problem, it's asking for like an actual real thing, like the bass and the trout, then you need to write it as an ordered pair.